Now, the question they are asking is find the value of x. If they were asking for the value of the angle, you literally would not have to do any math at all, which would be very cool. Now, don't make fun of my drawing because I'm not very good at it. It's really bad. So just know. Okay, so this is 43 degrees. And with these two notches here, as I call them, we are indicating that these two sides are equal. It's an isosceles triangle, okay? Now, in this case, if they were asking for the measure of angle 2 and it being an isosceles triangle, there's a rule that says whatever the one angle is of the congruent side at the base of the other congruent side is equal. So we know that if this is 43 degrees, this is 43 degrees. But that's not what the worksheet's asking for. It's asking for x. So that means that we need to say that x plus 48, this is a straight line. We could do one of two things, okay? You would think, but don't get confused by this. Do you think I should make it equal to 180 or equal to 43? That's where you need to clarify. Anybody? Should I make it equal to 180? Because it is on a line, right? I mean, come on. Or because they're both interior angles, not on opposite sides, should I make it equal to 43? I'll help you out.
Equal.
That's right, because remember I said that the base of the angle of one side and the base of the other with isosceles are equal? So obviously they don't equal 180 because 43 and 43 is not enough, but they are equal to each other. So now, remember in solving for x, I need to get x by itself. It's being added to 48. I need to undo that or do the opposite. And whatever I do on the left, I need to do on the right. Okay, now 43 minus 8 is -5. And I'm done. But some of you are like, wait a minute, can you have a negative angle? No, you can't have a negative angle, but we're not solving for the angle. We're solving for x. And if we were to plug in x, okay, for measure of angle 2, and we solve the problem, -5 plus 48, oh look, it's 43, and look, it's 43. It checks out. Does that make sense?
Another way that we can look at it is this problem has information that that is really not needed. Okay. Tracy, if we cover the rays, I'm making the outside angle, those lines are not needed. They're there to confuse you guys.
These are not needed, okay? All you need is the information here and these two hash marks to tell you it's an isosceles triangle, which means the two base angles are equal. So you know how to set it up.
Yeah,
okay?
if you ignore the two rays on the bottom, then you realize you don't have to look at the 180, but you have to look at it, the base angles equal to each other.
Right. So technically how I should have written it to start out is the measure of angle 2 is equal to 43, but they're not asking for the measure of angle 2, so I have to plug in what is the measure of angle 2, x plus 48, and then solve for x. Do you want me to do another one? Okay, let me do number 6 because it's a similar problem. Okay, and he's recording this, so if you didn't catch it, it'll be on.
Put it on YouTube later on. Not on
right.
YouTube, but we can put it in Google Classroom.
Yes, and I'll zoom out to show both of them in just a second. Okay, again, don't make fun of my drawing. I'm not very good at these. This is why they have indicators for those of us that can't draw. I know the sides don't look the same, but they are. It's pretty bad. I should bring a ruler to my area here. Okay, so this angle is 45 degrees, and then we have 2 up there. All right, so isosceles triangle again. Angle 2 equals 2 plus 11x. What we have to figure out is, do I add angle 2 and 45 to make it 180, or are they equal to each other? it's always one or the other typically when you're only dealing with two angles, okay? Now, these are what you would call alternate interior angles. Okay, and remember when we dealt with parallel lines, alternate interior angles were, if you remember, congruent, okay? So what that means is we're gonna make angle 2 equal to angle 45. So to write it out algebraically, we would say measure of angle 2 equals 45. But again, we're not finding out the measure of the angle, we're finding out what x counts for. So now I have to substitute the measure of angle 2 for 2 plus 11x equals 45. Okay, and now you simply undo the problem or get x by itself. It's being added to 2, so I subtract. And whatever I do on one side, I do on the other. 11x comes down. 45 minus 2 is 43. Am I doing this right? No.
I see.
Yeah.
You're assuming that the lines are parallel.
I am. Oh, I didn't know that
And those
information.
don't press it, I just put mistake. I mean, because you know, we all make mistakes.
I did do make this.
So just right above it, mistake, and don't erase it. Don't worry about it.
Okay, so I realized, and you know what tipped me off, you guys, is I'm like 11 can't go into 43 evenly. And typically the answers are even, they're not decimals. So I'm like, that doesn't sound right. Let's start over. Okay, so that theory doesn't work. So now what do I do? Let's do this. If this angle's 45, I know this one's 45, which would mean that if I use my handy dandy calculator, there's always more than one way to do this. I know all three equal 180. So 45 and 45 is 90, which means this one has to be 90 to equal the 180. So now angle 2 is actually equal to 90 degrees. And that makes much more sense. So now I substitute angle 2 for 90, subtract 2 on both sides. This makes much more sense. Bring down the 11x, and this is 88, which, see, you want a double number for 11. That's the first thing that tipped me off with the 43. X equals 8. So Mr. Rivas was right. I was thinking about parallel lines and transversals, and there's not another parallel line to tell me that. So I have to realize that, well, I know this is 45, and this side's isosceles, so the base of this one's the same. When I add those up, it's 90, so this one has to be 90. So now I know to make a measure of angle 2 equal to 90, because here's why. It's a line. It equals 180. Well, if this is 90, this has to be 90 because it's cut in half. If I didn't remember that, this is a line. The other way to solve this would have been to take measure of angle 2 plus 90 equals 180, and then substitute in the information for the measure of angle 2 and solve it that way.
Yeah, because there will be a linear pair.
Right. Okay. Combine like terms and then start separating. And you'll end up having the same thing. Okay. And X is still 8. So there's two ways to do it. If you remember that the opposite, if this is 90, this is 90, that works, and you can do it this way on the left. If you're not remembering that, just make angle 2 plus 90, because it's a linear pair, add the two together and do it this way. You'll get the same answer.
Another way of doing it is the exterior angle theorem,
That's true too.
but that's kind of tricky to see it.
Yeah.
In.
I didn't want to confuse them since I
Yeah,
already messed up the first
we're
time.
getting into problems that there's more than one way of doing it. And regardless of what method you use, you get the right answer.
Right. Oops, that's not where I wanted to go. I wanted to zoom out so you guys could see both problems.
Somebody said, made a comment on the chat that how do you know when it's 180 and when they're equal?
That's all depends on the information it gives you. So give me a problem, for example, and I'll talk you through it. And I can't see the chat right now, so you don't have to tell me.
Miss,
Yes.
someone in the chat said that the screen is just black and they couldn't see anything you did.
Okay.
Black for anyone else? I can see it.
I don't know.
I can see it. Can anybody else see it?
I can see it.
Okay. For those of you that it's just black, we'll post this video to Google Classroom and you should be able to see it then, okay? So don't do 3 and 6. You can follow along for 3 and 6. Thank you for letting me know. Okay, so give me, let's see, how do you know whether it's equal to 180 or equal to the other angle? Let's look at another one. You did number 8. Okay, let's look at, sometimes it's not a matter of 180 either. Sometimes it's a matter of just knowing that a triangle, depending on what the information gives you. So for example, let's do number 10, because number 10,
I got it.
oh, I already did, sorry. Number 10 is measure of angle 2 equals x plus 71. What we have to look at is what information is the triangle giving us, okay? And again, what is extra information? Like this ray out here is probably extra information. This top angle is 50 degrees. These lines right here mean it's an isosceles triangle. So that means that this angle too is going to be the same as this base angle. So here's the tough part on this, is you have to go, well, if this is 50 and the whole thing equals 180, how do I know what these two angles are? Well, my way of thinking of it is I'm going to say, well, 180 minus 50 is 130. That has to cut in half evenly between these two. Okay, so I need to divide 130 by 2, which gives me, anybody? 65. Okay, so that means angle 2 is 65 and this one's 65 degrees. And again, remember you're solving for x. So in this case, because it's isosceles and this is the base angle, I'm going to make this angle equal to this one. So it's hard to know whether to make it equal to 180 or equal to itself. You can do it one of two ways. If you're set on making it equal to 180, you can do that. And this is how. You take the 50-degree angle, you take the 65-degree angle, and you take angle 2, and you add it to 180. Okay? Then you substitute for angle 2, so 50 degrees plus 65 degrees, plus then you put this in, x plus 71 equals 180. And then you add 50, 65, and 71 together. And you get 186. So now it's x plus 186 equals 180. You get x by itself. Okay. And x is going to equal -6. And again, that always throws me off because I go, an angle can't be -6. We're not going for the angle. We're just solving for x. Now, the other way to do this, if you want to make it equal to 65, is angle 2 equals 65 degrees. Substitute for angle 2. Okay. Simply subtract 71. And guess what? X is -6. Same thing. So technically, all of them are equal to 180, but you have to make sure you include all the angles. So in this case, I included the 50-degree angle. I figured out that this one's 65 degrees, and then I added the angle 2. Substituted the value of angle 2 for x plus 71, added like terms, subtracted from the other side to get just x. So if it makes it easier for you to make all of them equal to 180, you can do that, but you have to include all the information.
Also, this problem has information that is not needed. Is there
Right.
only to confuse you?
Like this extra angle here, you don't need that.
Yeah, you don't need it. It has no information that it's needed for the problem. So if you
Okay.
ignore that, then it'll make solving the problem a little bit more easier.
So look at number 9. I'm going to help you set up number 9. I'm not going to do it for you, but I'm going to help you set up number 9 because there's several ways to solve it. Again, we have a triangle with an extension. That's extra information. We have these hash marks on all 3 lines, which tells you something. But if you can't remember what that is, at least know that these 2 mean it's isosceles. So all these triangles he gives you are at least isosceles, okay? At least. So say I don't remember what these 3 hash marks mean, but I know that these 2 mean isosceles, meaning these 2 are the same. I can go about it the same way where I take 180 minus 60 and get 120. I divide that by 2, which gives me 60, which means this angle is 60, and angle 2 is 60 as well. Now, if I remember that these 3 hash marks mean it's an equilateral and equal angular triangle, meaning all the sides are equal and all the angles are equal, then all 3 are 60 degrees, and I can make angle 2 equal to 60. So there's 2 ways to set it up. You can take 60 plus 60 plus a measure of angle 2 and make it equal to 180. Or you can take measure of angle 2, whoops, sorry, my brain's going too fast, and going faster than brain, and make it equal to 60. Either way, you still have to substitute in the value, which I forgot, measure of angle 2 equals 68 plus x. This is important because this is what you're subbing in for. So 60 plus 60 plus 68 plus x equals 180, and then you solve for x, or just take 68 plus x, make it equal to 60, and solve for x. Either way will give you the same answer. And I'm not going to solve it because I set it up for you now. All I have to do is the math. Here you have to combine like terms and then subtract it from 180. Here you just take 68 from 60. Does that make sense? Kind of.
That's what makes these problems a little bit complicated. There's
Right.
many ways you can solve it. And they throw basically from, linear pair, vertical angles,
Right.
triangle theorem. Basically, they're throwing everything that you learned so far.
And guys, you do not have to be perfect at this from the get-go. Okay, we're going to review this. You're going to have this again. And don't feel bad. Like I said, I'll always own up. I flunked geometry the first time. This kind of stuff blew my mind. Okay, until I did it time and time and time again, and then all of a sudden it made sense. What really helped me was owning a construction company. Then all of a sudden I was like, oh, I had to apply real world to it.
Yes, you have to understand that when you learn something, you're gonna make a lot of mistakes.
Yeah, and that's okay. We do too, because like I said, I'm dyslexic, so I write things backwards. I see things backwards. My brain is just, so don't feel bad if you're like, I'm lost. Just ask. We're not offended.
And every mistake is a learning experience, learn from it.
That's right. I think I've given you guys, good.
Ready.
So number 7 says the measure of angle 2 is equal to 7x plus 12. And it gives us this upside down isosceles triangle. And how do I know it's isosceles? Because it has these 2 little red, mine's not red, tick marks, okay? This is a measure, this is angle 2. We don't know its measure. And this is 49 degrees. Now, the 2 then bold indicates the angle number, not the angle degrees, okay? So this is 49. This is technically the base. If you turn it upside down, you have isosceles triangle. You can see it. So if this is 49, sorry, it's auto-focusing. then what is this one going to be? Remember, isosceles triangles, the two base angles, the opposite of the two sides that are equal are also equal. Okay? So I know, because of that, that if this is 49, then this is 49. And now I'm going to set it up. I'm going to say, there's two ways to do it. I'll do the first way. 49 degrees plus 49 degrees plus angle 2 equals 180. Because all triangles equal 180. The interior angles equal 180. Okay, angle 2, I have to sub in what its value is. Its value is 7x plus 12. Okay, oops. And that equals 180. Now, I combine, I didn't put the degrees here, sorry. I combine like terms, these three, okay, and I add them up. So I say 49 plus 49 plus 12 equals 110 plus 7x equals 180. Now onto the base of a typical problem. I need to get x by itself. I have an add-on and I have a multiplier. I have to do the opposites of those. An add-on means I'm going to subtract. And whatever I do to one side, I got to treat the other side just as equal. If I give you all one a cookie, I give one person a cookie, I got to give you all a cookie. That's how it works. This zeroes out because it's 110 minus 110 is nothing. 7x comes down, and we subtract 180 and 110. 0 minus 0 is nothing. 8 minus 1 is 7. 1 minus 1 is nothing. You have 7x equals 70. X is still not by itself, okay? It's being multiplied by 7. The opposite of multiplication is division. If I'm going to divide over here, I got to divide over here. This goes away, leaving x by itself, exactly what I wanted. 7 goes into 7 once. 7 goes into 0 none. And x equals 10. Now that's the basic, okay, if you want to keep it equal to 180.
What I like about this problem, there's no extra information that you don't need it, okay?
Correct.
Just give you what you need, so it shouldn't be that complicated to set up.
For those of you that want to do it shorter and it makes sense to you, you can simply say to yourself, 180 minus 49 minus 49, okay? And what is that? That is going to equal, you use your calculator, it's going to equal 82, okay? So then you know this angle, measure of angle 2 equals 82. But I have to sub in for angle, measure of angle 2, the 7x plus 12. And then I just go about solving it the exact same way. So for those of you that this makes sense and you don't need to do all these steps to see it, you can do this as well. Either way will give you the same answer. I'll even do it for you. See, they start to match. Okay. And look, I got the same answer. This is a lot shorter, but you have to know how, you have to understand the basis of how this works first. This is probably one of the hardest concepts you guys will learn. Well, right now. Wait. Okay, I'll show both in just a second. So if you missed copying it down, I'll show both. So number 5, the measure of angle 2 equals 18x, whoops, no, plus, minus 6. Minus 6. And this is a isosceles triangle on its side. This is extended, and this is extended, This is angle 2. These marks tell me it's isosceles. And then I have this 150. Okay. This is kind of a challenging one. So how do I go about solving this? Well, I know that this is a line. And I know that this is a line. What else do I have here that would be the same? Okay, think about it. This is my line. These two angles equal 180. I know part of it's 150. So I'm going to take 180 minus 150, and that gives me 30. So this is 30. Okay? This is an isosceles triangle. If this base angle is 30, then this base angle is 30. Now I know I can solve it. 30 degrees plus 30 degrees plus angle 2 equals 180. I have to substitute angle 2 for 18x minus 6. 30 degrees plus 30 degrees plus 18x minus 6 equals 180. I need to combine my like terms and make sure you keep this negative. That negative 6 is important. And then solve it. Okay? Try that on your own.
Miss,
Yes.
so we know that it's equal to 180 when there's like a number outside of the triangle.
Typically, if there's a number outside, you're looking at a linear pair.
So that
Okay.
means it's equal to 180.
Yes. And you need to do the math to figure out that inside angles to then do the triangle. Because all of them are at least isosceles. So all of them at least have two angles that are the same. Okay?
But what if there's no like number outside the triangle? So we equal
Then-
it to the number.
All the triangles equal 180. Give me an example. Like, what are you looking at?
No, I'm just wondering like how that works.
It's hard to know, and it's just practice. But like on this case, it's a linear pair to get that inside angle, to then know that all three equal 180 on the inside. All triangles equal 180 degrees, all three of those angles. Okay, that's just an unwritten rule. Well, it's a written rule, but all triangles, their angles equal 180. So if you can know two of them, you can find the third. So there's another way to do this. You could say 180 minus 60, and that equals 120. So angle 2 equals 120. You could say the measure of angle 2 equals 120, and then substitute that 18x minus 6 and make it equal to 120, and solve it that way too. And you'll get the same answer as this one. It just depends which one makes more sense to you on setup. And again, if you're lost, remember, we have tutoring tomorrow morning at 7:35. You can
Where'd you
practice
get the
these.
-6?
Say again?
Where'd you get the -6?
It's right here.
Again.
It's right here.
Oh.
It's the value. You have to
Okay.
substitute angle 2 for this because we're solving for x.
Okay.
Just hang in there and keep trying and come to tutoring tomorrow because I know it gets confusing.
Yeah, the problem is, this problem involves linear pair and then triangle sum principle. And the problem is, it's hard to see the linear pair. You have to learn what to ignore and what to focus on.
Exactly. And it's practice on knowing what these, equal. And again, this is just an alternate way of setting it up to this. These are the same.